Hello everyone, this is Nishanth here from third year BTech IT, and this video is for the RECode coding challenge conducted by the coding club of PSG Tech. So the problem statement that we are given with is the super egg drop. It's a LeetCode hard sum with an acceptance percentage of below 25%. So the problem statement goes like this. There are k identical eggs and we are given a building with n floors and it is indexed from 1 to n, and there exists a floor F where if we drop an egg from the floor F or any floor below it, the egg will not break. And if we drop it from any floor higher than F, the egg will break. And if the egg breaks, we are not allowed to reuse it. But if it does not break, we can reuse it in the future moves. So our aim is to find the minimum number of moves to tell with certainty that the value of F that we find, that the floor is the pivotal floor. So this is the algorithm which will be using dynamic programming, where we'll be initializing the DP tables, which will be discussed in the upcoming part of the video. And this is the optimal substructure that we will be making use of. And the ultimate answer that we are going to be looking for is in the last cell. So as I told you, dynamic programming is being used. But before diving into it, we must first understand in clear what this pivotal floor is. Say for example, if there are 6 floors and 3 is the pivotal floor, what if I were to drop an egg from 3, that is the third floor? It will not break. And what if I were to drop it from the second floor? It will not break as well. If I drop it from the first floor, it will not break. As you can see, any floor above the pivotal floor is going to result in the egg being broken. For example, if I drop it from the fourth floor, it will definitely break. So floors below the pivotal floor, the egg being dropped will not break, and any floor above it will result in the egg being broken. So 3 is like the safe point for dropping all these eggs, and our aim is to find this pivotal floor. So we'll be finding the worst case in order to tell with 100% guarantee that the floor we find is the pivotal floor. So this is the function structure that we'll be making use of. It has two parameters: total eggs, which is the total number of eggs that is given to us in order to find the pivotal floor, and this is the total floors in the building. So if in this example there is one egg and 6 floors, so how do we go on to find the pivotal floor? So say let us drop it from the 6th floor, that is the topmost floor, and we have only one egg. Is this a good move? Well, definitely not. Since we have only one egg, if we were to drop it from the 6th floor, and what if it breaks? We are left with no eggs to find the pivotal floor, right? So the logical thing to do is to start from the very first floor. And while dropping it from the first floor, if it does not break, what we do is we go on to the second floor and we drop it. And if it does not break there as well, we go to the third floor. And similarly, we reach the 6th floor and drop it. We only reach the 6th floor if it does not break at the 4th, 5th floor also. So when there is one egg given and 6 floors, the answer that we'll be returning is 6, which is equivalent to the total number of floors. That is, the idea is we are not going to take the risk of dropping it from the highest floor, but we'll take it step by step, checking at each and every floor. So the minimum number of moves that is needed here is the total number of floors, and this is the base case number 1. So what if I was given 100 eggs and only one floor? So no matter how many eggs I have, if I'm going to drop it from the first floor, it's just one drop that I'll be doing, right? So the answer in this case will be 1 as well. Say if we are given 10,000 eggs and 0 floors. Since we are given 10,000 eggs and 0 floors, the answer is going to be obviously 0, because we are not going to do any droppings. That is, we are not given any floors to work with. So the minimum number of moves that is required is actually going to be 0. So this is the summarization of the two base cases that I have discussed. That is, when the total flows is equal to 1 or when the total flows is equal to 0, we'll be returning the total flows. And if the total eggs is equal to 1, then we'll be returning the total flows as well. So let's see when there is 3 eggs, what will happen then? So let us first do a simulation for all these floors. That is, we do a simulation for the 6th floor, the 5th floor, the 4th, as well as the 1st floor, and see what happens. So when dropping it from all these floors, there are only two things that can happen. Either the egg breaks or it does not break. So these are the functions that we'll be using, and this is the no break and this will be the break. That is what will happen if it does not break, and this is for what will happen if it breaks. We have 3x and 6 flows. Since this is the case for no breaks, we are left with 3x, right? So if it does not break, we are still going to be left with 3x, right? So we'll be filling 3 here for all these values. So what do we do about the floor? Say for filling the no break case, if we are going to fill the total for the flows, we are going to use the formula total flows minus the simulation floor. Here the total floor is 6. Say if you are dropping it from the 5th floor or the 6th floor, that is going to be the simulation floor that we are talking about. So initially if you are taking 6th as the simulation floor, it's going to be total flows 6 minus the simulation floor 6. 6 minus 6 is 0. What does this 0 mean? 0 means that is the amount of flows that we are left to work with, and we'll be filling the value of 0 here. So let me explain it clearly with another example. If 5 was to be the simulation floor, what will we do? It is the total floor 6 minus 5, the simulation floor, and the answer is 1. What does 1 mean? 1 is the amount of flow that we are left to work with. That is from 5, if we are dropping it and the egg does not break, the logical thing to do is try it with the higher floor, right? So here we are left with one higher floor to try with, that is the 6th floor. Previously we had no floor to try with, as since 6 was the topmost floor, right? So we have filled with all these values, and the next thing is what if the egg goes on to break? What do we do then? So if the egg breaks, we initially had 3 eggs, right? So the amount of eggs that we have now becomes 2. So we'll be filling 2 for all the values. And what will happen to the simulation floor? We had dropped the egg from, say, the 5th floor and it broke. So the if you're gonna drop it from the 6th floor, it's gonna break as well, right? So it's not a logical move to go any higher. So we are gonna try it from one floor below it. So if it's the 5th floor, the next simulation floor that we're going to try with is going to be 4. That is simulation floor minus 1. So if the simulation floor currently is 5, we'll be minusing it and the answer is 4. We'll be storing it here 4, and if it's floor 3, that is 3 minus 1, 2. That will be we'll be doing it here, and we'll be breaking it down until we get our final answer. So we'll be making use of dynamic programming, and this is the DP table where egg represents the rows and flows represents the column. So what does this point mean? It means there is one egg and one floor. So what does this point mean? It means that there is 2 eggs and 3 flows. So when there is no eggs, then we cannot perform any drops. So no matter how many flows, 0 is going to be the answer. So this entire row is filled with the value 0. So when the floor is 0, so how many drops do I have to perform to tell with guarantee that the floor is the pivotal floor? So here, since the number of floors is 0, I have no floors to work with. So the answer is going to be 0 here as well. So we'll be filling the columns here with the value 0. Say for this floor, when the floor is 1, so no matter how many eggs I have, be it 1, 2 or 3, I will do only one drop. So the value that we'll be filling here is gonna be 1. And if you're gonna have one egg, what do we do then? So we'll be upper bounding it to the worst amount, which is the flows. So here it's gonna be the amount of flows 2, here it's gonna be the amount of flows 3, and it's gonna be the amount of flows 4. So this is the final answer that we are actually looking to find. We'll be solving all these subproblems to get the answer of this part, that is the last cell. So this is a subproblem that we are going to solve next, and how it goes is we have 2x. We are going to simulate and see what will happen if there is 2x and we drop it from the first floor here, and if there's 2x and we drop it from the second floor. So we'll be doing the same approach as I previously discussed, where this is the no break condition and this is the break condition. So initially we had 2x. If it does not break, the count of x will remain the same, that is 2. So 2 will be filled here. And what if it breaks? Then we have one egg less. So it becomes 2 minus 1, 1. We are left with one egg. And this is when the egg does not break. That is total number of floor minus the simulation floor. Here the total number of floors is 2. and the simulation floor is 1, so 2 minus 1. Here it is 2 minus 2 because this is the second floor that we are dropping it from, and this is when the egg breaks, so we decrement the simulation flow, that is 1 minus 1, and here it is 2 minus 1. And if we solve it, this is what it's gonna look like: drop of 2 comma 1, drop of 1 comma 0, drop of 2 comma 0, and drop of 1 comma 1. These red color things are when the egg breaks, and the green color ones are when the egg does not breaks during the simulation. And if you look closely, the drop is actually the DP table that we have used, and we can find these values from the DP table from here. On filling the values, this is the values that we had got from the DP table, and this is the worst case. On finding the values from the simulation, we'll be taking the worst cases. So why do we add 1 to this worst cases? The reason that we are gonna add 1 to the worst case is that it signifies that we'll be dropping it from this sub problem. So 1 plus 1 is going to be 2, and that's the answer of the sub problem. And we'll be finding the answers of other sub problems as well, and the final answer that we are looking to find is in the last cell. So this is the coding part. Here we create the DP array, and this is the initial base cases initialization that I had initially discussed about, and this is the optimal substructure that we had used, and finally we will be returning the value of the last cell. And k here is the number of eggs, and n is the number of floors in the building, and the time complexity is k into n square, and the place complexity is k into n. So it has solved all the test cases in the examly portal. Thank you.